we're going to head to showing you a little bit of information about EarthChem and other systems that are operated at the Lamont Doherty Earth Observatory as part of the geoinformatics group. So I'm going to show you the three systems that you may be interested in: EarthChem, or chemical and mineralogical data of terrestrial samples. And it also hosts the library for experimental phase relations and the trace element partition coefficient database that Mark Yorso and Roger Nielsen Gotcho Stunisek have been working on and are maintaining right now. The Astromaterial data system is a new system that is still under development. The development started a year ago. And it builds an infrastructure for the geochemical, geochronological, and mineralogical data for astromaterials that are curated in collections held at the Johnson Space Center of NASA. But it will accommodate any data for astromaterials that are submitted to the system. And the third is SESAR, the System for Earth Sample Registration, which is a catalog of metadata of information about Earth, space, and environmental samples, and is part of the IGSN infrastructure, which is the IGSN Global Sample Number, a unique and persistent identifier for samples that has a lot of benefits in linking data, publications, and samples, and ensuring, long-term access to information about samples. So what are the services that these systems provide? EarthChem and AstroMat have, on the one hand, repository services where data that is submitted by users can be published and archived. But then we also maintain compilations of data, the EarthChem synthesis. Many of you might know it under the name of PetDB still, but as its content is broadening, we are naming it now the EarthChem synthesis and the Astro database. These are databases where individual values from larger data sets can be extracted, where users can actually generate their own customized data sets for data analysis and further data mining. And then the system of Earth sample registration, as I already said, has the service for sample registration and for users to obtain unique identifiers. We do the system development, we review and curate contributed data, and compile and harmonize already published data into these syntheses. But EarthChem, AstroMat, and SESAR are also really trying to engage the community in developing best practices, promoting best practices, and that's part of that is the workshop today to introduce these systems and basically facilitate discussions around the use of these data in research. And we participate in a lot of different national and international initiatives that advance access to research data, standardization of research data management, and so on. So the workflow in these systems is that for data publication and preservation at the EarthChem library and the Astromaterials repository, we offer interfaces for users to submit their data, and then we curate them. Wherever the data are appropriate, we take them into these syntheses like the EarthChem synthesis, the EarthChem portal, the library of experimental phase relations, and the Astro database, where curators take data from the literature and put them into this database, but also, as I said, data sets that were submitted to the repositories and that fit the focus of our syntheses. And then we run the EarthChem portal where the data that we curate in the EarthChem synthesis, but also data from external databases such as the German GeoRock database, the USGS National Geochemical Database, and other databases such as the Darwin database, which is run in Japan, are all included in a large index that can be searched and accessed. For access, we have primarily so far offered search interfaces as graphical user interfaces on the web, but increasingly we have set up REST services, and we are in the process of developing a new API-driven infrastructure for EarthChem and AstroMat, so that you can use these the data holdings actually through your own code directly.